Problem number 3. Angela flips a fair coin 3 times, and Brianna flips a fair coin 4 times. What is the probability that the number of heads obtained by Angela is the same as the number of heads obtained by Brianna? Well, on this one, I used casework. Okay, so I looked first of all at the case where nobody gets any heads. Okay, so that's our first case. And in Angela's case, let's see, for Angela, what's that going to look like? She's only flipping it 3 times, so she's going to get 0 heads. So that means she has to get all tails, right? 3 tails. And Brianna, she's going to flip the coin 4 times, so to get 0 heads, she gets 4 tails. Okay? And there's really only one way to do that, right? To get 0 heads. So let's take a look at what the probability of Angela getting 3 heads is. Okay, so she has a 1 out of 2 chance of getting a tail the first time, 1 out of 2 the second time, and 1 out of 2 the third time. So that gives her a 1/8 chance of getting 3 tails. And for Brianna, because she's flipping the coin 4 times, it's just 1 out of 2 times 1 out of 2 times 1 out of 2 times 1 out of 2. Okay, so in Brianna's case, it's 1/16. Okay, so that's the probability that Brianna is going to get 4 tails. All right. So let's look at another case where they each get 1 head. All right. So what does that look like for Angela? Well, she could get a head, tail, tail, or she could get a tail, head, tail, or she could get a tail, tail, head. Okay? And for each one of those possibilities, there's a 1/8 chance. So the calculation is the same. There's 1 out of 2 chance of getting the head on the first one, 1 out of 2 of getting a tail, and then 1 out of 2 getting a tail on the third one. So each one of these is 1/8. So if we were to add those all up, that's 3/8. Okay, does that make sense? So there's a 3/8 chance that Angela gets 1 head. Okay, so if you think about it, there's 3 ways to get, 3 places to put the head. Okay, and then once we have the order determined, then there's a 1 out of 2 chance for each outcome of the coin. All right, so that's how we get the 3/8. And for Brianna, now again, it's just 1 head, so it could look like head, tail, 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 or it could look like tail, head, tail, tail, or tail, tail, head, tail, or tail, 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 head. Okay, so here we have 4 places to put the head. Okay, it's only 1 head, and then the rest are going to be tails. Okay, and there's a 1/2 chance of any one of the outcomes. So each one of these outcomes is 1/16. So the total here is going to be 4/16. Okay. All right, so now let's look at 2 heads. All right, so 2 heads. So what does that look like for Angela? Well, there's only 1 tail essentially, so it's kind of the same issue. It's the same probability as this one up here, where it's 1 head, because essentially it could look like head, head, tail. You've got 3 places to put the tail. Okay, so you have the same number of orders, I guess, of sequences, and then you have still a 1/2 chance of each outcome. So this is again going to be 3/8. I didn't write out all the outcomes, but this would be heads, heads, tails, heads, tails, heads, or tails, heads, heads. Okay, that's why the 3. And then the 1/8 comes from 3 coins, 50-50 chance for each outcome. Okay, and for Brianna, so a little bit trickier. She gets 2 heads and 2 tails. Okay, so it could look like heads, heads, tails, tails. And we could list out all those possible orders, but essentially we've got 4 positions where the heads could go, and then the rest are going to be filled in by tails. So it's essentially 1/16, for any given outcome, just like it is up here. It's 1/16 times the number of different orders, which is 4 choose 2. And we get 4 choose 2 because there are either 4 positions to put the heads, and we want to choose 2 of them. Okay, so, and 4 choose 2 is just 4 times 3 over 2 times 1. Okay, so that's 2, so that's 6. So we end up getting 6/16. Alright, last one is 3 heads, because that's the most number of heads that Angela can get, because she's only got 3 coin flips, right? So hers is just going to look like heads, 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 alright? And that's just going to have a 1/8 probability for that, 50-50 chance for each coin flip. And for Brianna, it's going to look like heads, 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 tails. So essentially we have 3 heads and a tail. So we have 4 places where we could put the tail, alright, and then we have a 1/16 chance of any one of these outcomes. And so we have 1/16 times the number of places to put the tails, so that's times 4. Okay, so that's equal to 4/16. Okay, so now we have all the probabilities of all these different cases. Okay, 0 heads, 1 head, 2 heads, 3 heads. But now we got to find out the total probability of getting the same number of heads. So we've got to combine the probabilities for all these cases. Alright, so the combined probability of Angela getting 3 tails and Brianna getting 3 tails is just, 1/8 times 1/16. Okay, so what is that? That's just 1/128. Okay, the combined probability of Angela getting 1 head and Brianna getting 1 head, we just multiply these probabilities and we get 12 out of 128. Okay, and here we have a 3/8 chance of Angela getting 2 heads, and Brianna, her probability of getting 2 heads is 6/16. So 3 times 6 is 18, so that's 18 out of 128. And then 1/8 times 4/16, that's the case for when Angela gets 3 heads and Brianna gets 3 heads. So that's going to be 4 out of 128. So let's add all of these up. I'm going to kind of mark the rows I'm trying to add here, or the numbers I'm trying to add. So I want to add all those combined probabilities up, okay, for each one of the cases. So okay, so we have 1 plus 12 plus 18, so there's 31, 35, so that's 35 1/28. And 35 is 7 times 5, and 128 is a power of 2, so there's nothing we can't reduce that, so that's our probability, 35 out of 128. Now if you want to put that in a calculator and see what it is as far as percentage, because sometimes it's a little easier to get a handle on the numbers when you look at it out of 100. So that ends up being 27.3%. So it gives you a little bit better idea. It's a little more than 1 out of 4 chance that would happen, that Brianna and Angela would get the same number of heads. Okay? So that's your answer. There's a lot of probability work going on. So you get the important thing here is to know when to multiply probabilities and when to add probabilities. Okay, so here, these are subsequent events, and so we multiply the probabilities. And here, where we got casework, so we got casework here, 1 heads, 2 heads, 3 heads, and so on. We also have casework within the casework because we had, more than one way that you could get one head, for example. So then we added the probabilities. Okay. So this is kind of an advanced probability problem. But anyway, this is your answer, 35 out of 128.